1, 2, 3.
Hi, Assalamualaikum everyone. So today my group members and I want to share with you guys about our third topic in math logic, which is logical connective. Okay, so before we go through into the more details about this topic, let me introduce our members to you guys. So the first members is me, which is Syasya Binti Zamri, metric numbers 2020858038. And then our second members, which is Muhammad IZWAN SHAFIQ bin Muhammad ASRI, metric numbers 2020873946. And our last group members is Nur Ahmad bin BAKRI, metric numbers 2020826498. Okay, we get move to our next slide. Okay, so hi, my name is Syasya Binti Zamri. My metric numbers is 2020858038. So it's my turn to explain to you guys what is the meaning of logical connectives. Alright, so basically logical connectives is a logical constant that we use to connect two or more formulas such as two atomic formulas P and Q. Logical connectives is also called as logical operator. It includes negation, which is not, conjunction, which is and, disjunction, which is or, material implication, which is if and then it also includes biconditional, tautologies, contradictions, and contingency. So let's move our next subtopic. I will pass it to my friend to discuss with you guys what is actually compound statement.
Okay. Next slide is compound statement. A compound statement is a combination of two or more primitive statements using a connective, as known as a logical operator. The true value of compound statement is completely determined by the true value of its primitive statement. Some connective for two primitive statements, P and Q, are shown in the following table. In this table, P for the example first, two primitive statements are defined as follow: S, your handbag is stylish. C, I like its color. So in the connective, join primitive statement into a complex statement. Using connective and the two primitive statements S and C are turned to complex statement. That is, your handbag is stylish and I like its color. In symbol like S and C, the symbol N. The next example is two or more primitive statements are defined as follow: S, Fadil will play at the tennis. C, Fadil will go to the movie. And D, Fadil do both. Connective join primitive statement into the complex statement. Using connective or the two primitive statements S, C, and D are turned to complex statement. That is, Fadil will play tennis, or go to the movie, or do both. Okay, that's all from compound statement. Thank you.
Hi, Assalamualaikum and have a very good day to Madam Shamsatun and to all my friends. So today my name is Muhammad IZWAN SHAFIQ bin Muhammad ASRI. My metric number is 2020X73946 from JCS 143B. So for today I will discuss with you guys about truth table and truth values. So I hope that this discussion will give a little bit of new knowledge to you guys. Okay, so let us start it. Bismillah. So let us proceed to the first theory that you guys have to know in this subtopic. Okay, so you guys have to know the definition. Okay, as you guys can see in my slide, okay, I have prepared this for you. Okay, a true value is the truth or falsity of a statement, or we call it as a proposition. Okay, so the truth table displays the relationship of the true values of the statement. Means that if the compound statement has two variables, okay, let's say we have P and Q, or we have A and B, or any other unknown, okay, but have two, it have to be constructed with 4 rows. Okay, this is the concept that you guys have to know. Okay, for this course, okay, the maximum variable is only 3. So if you have 3 variables, okay, you have to construct with 8 rows. Okay, so next, okay, a truth table summarizes all possible true values of a statement. Okay, for example, P can only either be true or false. Okay, so P have 2 possible outcome, which is they can be it can be true or false. Okay, so for the true statement, okay, we declare it as 1. For the false statement, we declare it as 0. Okay, this is the concept. Okay, if it is true, then it is 1. If it is false, then it should be 0. Okay, this is the concept you guys have to know. Next, you have to know about negation. Okay, basically I can say that negation is the opposite, okay, true value from it, okay, from the variables itself. Okay, so the negation of a statement P denoted by that symbol, okay, I have prepared it in my slide, okay, and it is read as not P. Okay, this is the theory or the theorem. Okay, if P is true, then negation of P is false, and if P is false, the negation of P should be true. That means they have different meaning. Okay, so as you guys can see in my table, okay, I have put there. Okay, you guys can see if P is 0, the negate is 1. If the value of P is 1, then the negate should be 0. Just opposite the value of the true value. Okay, just simple as that. Okay, I hope that you guys can understand that well. The last thing that I want to share is, okay, if we are analyzing 2 statements, okay, P and Q at the same time, we need to consider all possible combination of the true value. Okay, so we have you guys can see in my slide, okay, I have put there P, Q, and then I have put there the negation of the P and Q itself. Okay, P0, the negate should be 1. Q0 should be negate 1. Okay, for this statement, for this variable, it only have 2 variables, so it should be with 4 rows. Okay, so we put there, okay, any like of your own a number that you guys want to put there, okay, but must be identical. Okay, for you guys can see there, I have put there 0011 for the P, and then the Q 0101. It should be identical. Okay, then the negate should be 11 of the P. Okay, the negation of the P should be 1100, and the negate of the Q should be 1010. There, thank you. That's all for me, and I hope that you guys have learned a little bit of knowledge. And yeah, let us proceed to another topic.
So the next subtopic is conjunction. Okay, so let me explain to you guys what is conjunction means. Conjunction used to combine any 2 primary statements using and to form a compound statement. The form has 2 premises, which is P and Q. Intuitively, it permits the inference of their junction and denoted by P and Q. Read as P and Q like I mentioned before. And if P is true and Q is true, then P and Q equal to true. Otherwise, P and Q is false. As you can see in the table, if P is equal to 0 and then Q is equal to 0, P and Q is also equal to 0. But if P is equal to 0 and then Q is equal to 1, P and Q will be 0. 0 means false and then 1 means true. So we move to first example of conjunction. Okay, so for example, the question mentioned that for premise P is equal to I play the piano, and the statement was false. And then for the second statement, it shows that Q is equal to I study logic, and the statement is true. So basically, the false statement will be P and Q is equal to I play piano and study logic. So it will be false statement because of the P statement is false and then the Q statement is true. So we will do the table first by shows using the 0 and 1, and then for P, if the P is false and then the Q is also false, the P and Q will be false statement. And then for note, in bracket, P and Q will be true. Because of why? Because there is symbol of not. And then when we implies that not P and Q implies to in bracket not P, which is when we say not P, it's mean from false statement, it will be true statement. So these are the final result. We can see that not P equal to 0, and then not P and Q will equal to 0 as well. Okay, let's move to next subtopic, which is disjunction.
Hi, Assalamualaikum. Next, I will explain about disjunction. Disjunction is used to combine any two key statement with the word or to form a combined statement. The speed of two statements P and Q is denoted by PVQ with S POQ. The true value of the POQ statement satisfy the following properties. If P is true or Q is true or both P and Q are true, then P or Q is true. Otherwise, P or Q is false. The otherwise is when P and Q is false, then the statement is false.
So these are the example of disjunction table, as you can see in this slide.
There are two simple questions, question A and question B. Question A is in the bracket P and Q, or in the bracket P and R. And question B is not in bracket P or not Q or Q. For question A, step 1, identify how many variables there are. In this question, there are 3 variables, namely P, Q and R. Step 2, solve the first bracket first, which is P and Q. And then just complete the second bracket, which is P and R. After finishing the one in the bracket, we can do the last step, which is to find the disjunction between the first and the second bracket, and done. That's all. For question B, it is same as the question A. Step 1, find variable first, then complete the one in the bracket first. In the bracket there is a have a not symbol on Q, so finish that first, then finish P or not Q. After completing the one in the bracket, then we can do the next step, which is the not in the bracket P or not Q. So lastly we can get the final answer, which is 1100. So that's all. Thank you.
Okay, for conclusion, what we can conclude that we have 4 logical connectives that we have been discussed in this subtopic. Okay, let us review again. For N, we have the symbol of the inverted V. Okay, P and Q. For this conjunction, which is OR, we have the symbol of V. Okay, which is P or Q. And then for implication or conditional, we have the error with the we have the single error. Okay, for the biconditional, P if and only if Q, we have the double arrow. Next, for negation, okay, which is not, okay, it is the opposite the true value. Okay, for example, if P is 0 and the negation of P should be 1. If the value of P is 1, then the negation should be 0. Okay, just opposite the true value. Okay. For conjunction and, both value should have 1, then it should be 1. Okay, so for example, if P is 0, Q also 0, the P and Q should be 0. Okay, 0. If P is 0, Q is 1, it should be 0 too. If P is 1, Q is 0, also 0. Okay, if P is 1 and Q is 1, then P and Q should be 1. That means both statements should have should have true statement. Meanwhile, for this conjunction, which is OR, okay, at least we have 1, then it should be, the statement should be 1, which is true statement. Okay, for example, if P is 0, Q is 0, then P or Q should be 0. If P is 0, Q is 1, then P or Q should be 1. Okay. Next, if P is 1, Q is 0, should be 1 because there is have at least 1. Okay. Then if the P is 1, then the Q is 1 also, then P or Q should be 1. Okay, for conditional statement, okay, P implies Q. Okay, that means for conditional statement, okay, we need to be considered that the statement is always true, okay, except if the one at the front of the statement. Okay, that means if P is 1, Q is 0, automatically it will be 0. That means false statement. Other than that, it should be 1, which is true statement. Okay, that's all for conditional statement. Lastly, for biconditional statement, okay, for this statement, okay, just easy. Both statements should be have the same value if they both are true. Okay. Lastly, for biconditional statement, okay, it is just easy. Okay, consider. Okay, let us consider if the two statements have the same true value, then it should be 1. Okay, if P is 0, Q is 0, then P by conditional Q should be 1. Why? Because they have the same true value. Okay, if one of them have different true value, then it should be 0. Okay, next example, if P is 1, Q is 1, then P by conditional Q should be 1. Okay. Other than that, if P is 0, Q is 1, it should be 0. P is 1, Q is 0, it should be 0 too. Why? Because both of them should, both of them do not have the same true value. That's all. So that's all from our group, and thank you for having us for today, and have a nice day. Bye. Assalamualaikum.